Okay, good morning, everybody. Today we are going to do calculations using spectral indexes, which we were discussing yesterday. There are two types of vegetation indexes. One is what's called ratios, where you will divide one versus the other. The key here is that both of them have to have the same units. In this case, this is reflectance over reflectance. You cannot do reflectance over temperature, for example. That's the idea is that the ratio is unitless, doesn't have units. If we divide reflectance over temperature, we'll have the units will be 1 over kelvins, for example. But when it's reflectance over reflectance, this index doesn't have units. The same happens here in the normalized difference form of vegetation indexes. As we subtract these two bands and divide it by the sum of them, the units of reflectance divided by the units of reflectance give us a unitless index. Okay, so these are the two primary forms. There are more complicated forms that are just a variation of this. For example, I've seen a form of this one where we say B1 plus B2 minus B3 plus B4 over B1 plus B2 plus B3 plus B. This is just a modification of this one in the case that we're adding two bands and we're going to subtract to that addition the sum of two bands. But at the end, we're divided by the sum of all the bands. Okay, so the thing is, these indexes have to tell us surface conditions. What do I mean by that? Surface conditions means that they have to describe what is happening on the ground or over water, the current characteristics. If we have a forest, it must tell us what's the condition of the forest, depending on the band. Remember, for vegetation, we have a region for chlorophyll, a region for nutrients, and a region for biomass. The optical bands were for chlorophyll, the red edge is for nutrients, and the near infrared is for biomass, and the short wave is for water. So depending on what we combine, what we decide to combine, we might find information about water conditions, vegetation biomass or health, or chlorophyll or photosynthesis processes. Now, how many indexes are out there? Hundreds. Every year, a new researcher can propose a new index. And yesterday, we created the MASUMET index, right? Where we sum RGB and divide it by near infrared, okay? What that index will tell us? Well, it's telling us the relationship between the chlorophyll absorption, the RGB, divided by the amount of biomass occurring in that plant. So it's relating chlorophyll conditions or carbon water exchange of the plant with the amount of biomass by the plant. So that's the interpretation of that index. So if we combine, for example, in the NDVI, which is one of the most common indexes, the NDVI is going to be the NDVI is the normalized difference vegetation index, and this is the most common. You will find it basically in any paper related to remote sensing of land surfaces. what is dividing is near infrared minus red over near infrared plus red. Okay. We know that the mathematical range of this index can go from -1 to 1. One of this, if comparing to the Masomet index, an arbitrary index that we invented yesterday, how do we explain this index? What is measuring? Okay, what the near infrared tell us about the vegetation?
Biomass.
Biomass. What is telling us red?
Amount of green. Red, no.
What is telling us the red bar?
Amount of water. No.
This is stress. This is chlorophyll.
Red is only for red and blue or just red?
The chlorophyll is red, green, and blue. The three of them. But the most important, the most important red and blue. Okay. So this index is relating the biomass, the overall photosynthesis process of the plant. So it's telling us if the biomass that we're observing based on the NDVI is related to this process by the plant. What it will tell us now, let's go more into detail here. Okay, now we know that NDVI is related to biomass, and biomass can be affected by what?
Can be affected by
From planting till the, let's say, the end of the year of any plant, tomato plant. What can affect the biomass?
Water availability.
Fertilizer.
Water availability.
Okay, water. Okay, what else? Nutrients. What else?
Climate.
Yeah, climate. Anything else? Soil?
Injury, like a
Soil.
set injury or something like that. Some kind of injury.
Okay, injury, disease, insects. Okay, so biomass is affected by all of this. Okay, and we might be forgetting one more. Okay, so what is the idea is that when we use a vegetation index, we need to be aware of what is that information, what that value that we will get means, because there are hundreds of indexes, and typically, if you use in a lightweight remote sensing, this probably is going to be the index that you will use the most. But there are other indexes, and I think in the next lecture, I'm going to give you a list of at least 50 indexes, okay? But it's our job to figure out what every index is telling us, okay? So in this NDVI, the biomass is affected by these conditions. So if there is lack of water or nutrients or injuries, diseases, the biomass will be lower, or it won't grow to its full development. Okay? In the chlorophyll, again, nutrients can be affected.
The amount of biomass is decreased, so amount of near infrared also decrease.
Yeah, the amount of biomass will decrease. It will be, the reflectance will be lower. For the red band, for the chlorophyll, the lack of nutrients, the lack of water, also the injuries, diseases, insects can also affect the reflectance here. So in general, this index, the NDVI, and this is why a lot of people love it, NDVI over all plant because it collects effects of climate, diseases, soil, water, nutrients. It's part of these two bands. We call it the overall plant health index. And this is the reason why many papers use NDVI, because from looking at the numbers, you get an idea if that area is healthy or has any issues. Okay, so the other indexes, depending on which bands are going, we need to relate what is measuring and what can be affecting that band to interpret the numbers or to interpret the values obtained. So in NDVI, we're going to find something interesting. In NDVI, we're going to find that there is a scale already. If NDVI is larger than there is a scale. Over time, we have figured out that certain values act like thresholds.
Most
So,
of them is for soil.
yes. So if the NDVI is higher than this value, it's healthy. The plant is healthy. If the NDVI is below 0.3, we're looking at soil. If the NDVI is very close to 0, it's water. If the NDVI is negative, it's soil. So that comes from replacing the reflectance of water, the reflectance of soil, the reflectance of plants from very early stages of the plant to the full development of the canopy, to full development of the leaves and the height and the biomass. So these quickly help us to identify issues or problems. Let's say if I'm cultivating corn, okay, this is a field that has corn, and I have, let's say, in average, here is 0.75. Here, let's say 0.6. And here I have 0.55. What can you tell me?
Maybe we can talk about the healthy of them, or maybe the variety of them is changing.
It's the same field, the same variety.
The same variety.
Less healthy as you go upward,
Healthy and
bottom right.
Yeah, it might be related. When is this type of trend? It might be soil. The effect of soil tends to be irregular, an irregular pattern, but it's telling me that here the plant has better access either to water or nutrients. While here, the same plant is having some issues. Yeah.
So could you use this to look at like if a farmer has like a leak in their sprinkler system, so one side's getting more water and
Yes, you can, for example, if you're going with that example, excessive water, too much water, okay, will also, it will hurt, it will wash out the nutrients in the soil. So if you have an irrigation system, Okay, let's say these are sprinklers. Okay, let's say, where is my blue marker? Okay. But let's say the center one is leaking more water. Okay. The NDVI that I will expect, the NDVI that we'll expect is that this region will have a lower NDVI than this region. Nevertheless, if I want to detect like leaks, thermal data will be better. Thermal data will show me a cold spot, exactly where the leak is. If the leak is happening in this area, I will see that this area is colder than the rest. But that's based on temperature. But yeah, these indexes allow us to tell what's happening in the ground. Okay, so NDVI is overall. So it's not telling you what is causing it because it might be multiple factors or one factor. It's like a thermometer. Okay, you get fever, but the thermometer doesn't tell you the cause of the fever. Okay, so what range of values is missing here?
Between. Yeah, between 0.3 and 0.75.
What's happening here?
Unhealthy plant.
Health is here.
Unhealthy plant.
It could be because we have two scenarios there. One is I have my plants, but I still in my pixel, I have soil.
Like impacted by genetic code.
So my development of the biomass is still too small. The other example will be that my plant, let's say, it should be like this, but I have a short grow. Okay, it should be the biomass must be more developed, but the plant maybe is being affected by lack of water or nutrients. So two potential answers for this. So until we don't do an inspection or we know, okay, we planted 2 weeks ago, the NDVI has to be lower. When we plant, we're looking basically at bare soil. So we start here, okay? And that value keeps increasing as the biomass of the plant keeps growing. In terms of alfalfa, corn, forest trees, what we call it, the cover of the vegetation, or the cover of the ground by the vegetation will increase. Here, at these values, we're talking about a coverage of almost 100%. So these gaps are minimal, very, very minimal here. But in the transition, we can have gaps. That gap is called the fractional cover. So what's the percentage of the ground that is covered by the vegetation? It's a rate. So I might have that in this distance, the fractional cover could be 50% because I still have 50% of the ground still exposed soil. And when the plant reaches here, the fractional cover reaches 1 because the entire surface of the ground is covered by leaves. Okay, we will keep discussing on this, but the idea to, yeah, go ahead.
You know if there's any challenges with using NDVI for like really woody plants like sagebrush or something like that? Or Or even like dusty plants like growing out there?
The restrictions are going to be here. These thresholds, especially this one, were designed for very healthy plants. This is agricultural plants where we provide water, nutrients, we take care of the diseases. So the plant is able to develop to its full potential. But in nature, like let's say the wetlands or the forest here in the canyon, don't reach this value or are able to reach, but in agricultural fields, you see this value reach 0.9, so extremely healthy. But in forestry, they barely reach 0.75, 0.8. So it's slightly lower. So in those conditions, this threshold might decrease, can decrease to 0.6, for example, and we call that forest healthy. Because remember, the plant itself is figuring out the nutrients and the water and dealing with the climate effects and the injury of the plant. Okay, but for every vegetation index, again, we look at the bands. As we are the remote sensing expert, we relate every band with a specific condition of what we're looking at. And red tell us a story about biomass. Red tell us a story about chlorophyll. The factors that affect these bands is important. And with that, we make sense of the values. Okay. Okay, with that intro, now let's go to HydroShare Jupyter Lab.
Question about the soil, you give us two range of the, okay, what is different between them? I mean, this kind of soil cover this range and which one?
Oh, what happened at soil?
Yeah, because you,
Yeah.
provide if you want.
So you will plant a crop over soil, right?
Mhm.
The reflectance of soil, the near infrared and the red are almost the same value. When they're similar values, the index is very low. So this is a threshold that allows us to separate soil pixels from vegetation. Over this, in this range, we might find that there is vegetation in different conditions. Still we can see soil between the vegetation, or the development of the vegetation is still limited.
But about the NDVI, I understand zero is just soil.
Yes.
Mhm.
This is when it's less than 0, when the red is larger than the near infrared, which only happens on soil. Remember the NDVI being higher than the red. So as this decrease, this other situation is soil. Okay, so let's open the lab number 3, and we will run this lab to calculate indexes. Let's see if we're asked to get the Earth Engine topic. One piece of information I gave you several times during this class is that every material in the plant has a spectral signature. So here is an example of snow, water, sagebrush, or as native vegetation, soil, dry grass, Douglas fir, I don't remember that one, concrete, asphalt, and the aspen trees. Asphalt, the values are kind of the same in the RGB. So they have similar values, but it flattens in the other wavebands. Concrete, similar behavior, but with a drop in the signature of one of the water absorption bands. The thing is, plants will always have the red edge, here or here. Soils don't have that red edge. They start greasy. Then they have the water absorption bands, but it's like a concave shape. Okay. Is everybody able to open the notebook? Okay, let's see. Oh, I need to update the GEEMAP. Pip install -u GEEMAP. Okay. Let me rewrite this one. It's taking too long to want to restart my kernel. Okay. 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 Okay, here we can use the example that we have, the coordinate for a point around Logan, Utah, or again, we can use any location of our interest. Is this fine? We already know how to get the coordinate for any location in the planet, right? Okay. Let's see here. We're importing Landsat 8. We are importing it around the latitude and longitude we defined. And this is for last year from June till September 1st. We are sorting it by cloud cover land, bringing the surface reflected values, or adjusting it by the coefficients given on the website. The true color here, we need to pay attention to the bands. The first band is coastal blue, the second is blue, then red, green, or blue, green, red. So it's 4, 3, 2. So I'm selecting these bands, 4, 3, 2, red, green, blue, minimum 0, maximum 0.5 reflectance. Print the bands or the band names, and here we get our map. Let's see. Why is failing? Token has been expired or revoked. Huh. All right, let's do that. Okay. My token failed, so. Okay. Let's see. Let's rerun the cell. I need to rerun everything. Let's see. There we go. That's Logan, Utah, seen from the eyes of Lancet. This is an RGB picture. Is everybody there? Okay. Okay. Now, in this line, the good thing about Google Earth Engine is that the equation or the formula for the normalized difference is already there. If we tell them the bands, the order of the bands, it will calculate the index for us. We can use then a palette of colors to tell which colors we want to express. Now, this is one trick we do. When we plot values, we tend to do it from 0 and up. When we plot NDVI, we don't plot or we don't assign colors to the negative values. Because there are very few cases where this happens, the NDVI being negative. But if that happens, we know that this soil. There is no other explanation to that. So we tend to plot NDVI from 0 to a higher value. But we can check how it looks like. And here it is. Should get a map like mine. What does it mean? What does it mean, this map? Okay. Okay, let's explain. Let's think about the colors we use. We're going to plot from 0 to 1. The lowest value is going to be related to white. The highest value is going to be related to blue. And intermediate values are going to be red, yellow, and green. But they're going from 0, which is white, to blue. So the reddish, yellowish the color, the NDVI is lower. The green towards blue, the NDVI is higher. Okay.
Is blue just super healthy?
Let's see how healthy it is. So you see these very blue intense fields there? Zooming in there. You just need to double click the map. Okay. Okay, I want to show you what I was just drawing on the board. What do you see in this field? Is NDPI homogeneous? Is the same color all across the field? No. Now you know your table of NDVI. So let's start querying. So go to the range, click on the eye, the inspector, and click NDVI 0.88. Now let's click on the less or on the greenest part. .7. So according to our table, it's kind of close to healthy, right? Nevertheless, these areas are much healthier than these ones. Can we see what's happening in there? Well, yes, we can, because we have this option. Okay, this is not super clear. We need to, oh, we put 0.5. Let's put it 0.3. Let's run that cell. Let's run this cell. There we go. Where is my NDVI? Did it show my NDVI? Okay. Oh, it's still asking for this. Okay. So I can see, you can see very green in the RGB, but you can see that this area is less green. So we might be under this condition where we have exposure. So the plant is growing, but is the density of the biomass is not enough to cover the ground. So there might be, and this happens, there might be a pocket of sand. Soil is extremely heterogeneous and will affect, in the same field, you don't have the same soil type everywhere. So in some extreme cases, you can have a different soil type that can have less water retention, or a layer of let's say clay that retains water, reduce oxygen, and the plant grows slower. That will be affecting our results or our numbers. Let's activate the NDVI. So in this case, my map, I can query, let's say, this one. And this one, this is interesting, but I don't know if Kurt can recognize your data in here. There is a sort of stripes that are slightly less blue. This is soil composition. And Kurt, who has been doing soil mapping with it's called electromagnetic sensor, he found that some of the fields in Utah, in Santa King, the soil have different stripes of, or different texture soils in diagonal stripes. So here is quite visible in this field. We keep looking at these fields, and we can have other types. We have, let's say, lower retention, water retention, and here we have higher water retention, or a different or more clay material in there. That's on the fields. Look, if we look up, we find center pivots, and center pivots are my favorite because you are bound to a geometrical shape. Okay, who can tell me what's happening in this field? First, is the NDVI homogeneous in at the center pivot? Now, what's happening? Do we have low and high regions? Yes. Do they resemble these regions high and low, resemble geometrical shapes. When they resemble geometrical shapes, like how the center pivot is blue and the other is green, that might mean that the producer was harvesting here when the picture was taken, and the other half is still bound to be harvested. Okay, but that's when you find like very clear differentiation, like geometrical shapes. But in this case, is this lower blue region seems to be divided geometrically from the intense blue region? What do you think? Yes, no? Probably not. It seems that this area has its own behavior difference to that. But what about this? This is a geometrical shape. This is a line. What is that? It's a road. That's the road, the entry road to the center. Because the control panel for this center pivot is here at the center. So they need a road. And despite this pixel data is 30 meters wide, the effect on the NDVI is very clear on those pixels. Okay, what about here? Do you see geometry in there? Like concentric circles. Do you see that? Okay. What could explain concentric circles in a center pivot? Like you're having variations of light and dark blue. What could explain?
Broken.
Huh?
If one of the sprinklers is broken, like every time it goes around, the sprinkler's not irrigating.
Yeah, so a satellite, Landsat might not be the best. Probably Sentinel with 10 meters or Planet will be better to detect this, but we can use remote sensing to visually evaluate center pivots, like the sprinklers uniformity of irrigation. But this, if we are seeing concentric circles in Landsat, then the issue with the broken sprinklers is huge. Because this is 30 meters, this is 100 feet wide. So to be seen on that scale, this center pivot needs a visit from the irrigation dealer soon. Fun? Okay.
Good question.
Yes.
Why would Bear Lake have a lot of red, yellows, and even some green blues stretching across it?
Okay, where in Bear Lake?
I mean, kind of everywhere, but on the southern shore,
Okay, here.
Like inside the lake.
inside the lake.
Oh, inside the lake. Okay, that's a good question. Let's see the RGB. Okay. To see water, we need to reduce the, sorry, this value, this 0.3 to 0.1. Let's try the RGB. We're going to make it more stretch. When you need to see water, you need to stretch it more, or the higher value has to be. Okay. Let's go to Bear Lake.
So it's easier to see now.
Okay, you see it now? We sort of have vegetation in the water. We sort of have either algae in the water. And that's true. There are stripes of vegetation in Bear Lake. Right? It's not everywhere, but I'm not sure if this is a very low. This is 2021, right? Well, 2021, I think the lake was at the lowest, or the reservoir was at the lowest. But yeah, it seems that there is vegetation in it. And that can explain the NDVI values there.
That makes sense. Also, when you got NDVI open, there's both black and white. Well, white is just zero, so that's water.
Let's query.
I guess it's not black, it's just.
Okay, let's query it.
Yeah, how do they differentiate between the white and the red?
Okay, here where I clicked, the NDVI is 0. Here in the white, this is sand.
Oh,
Negative. Okay, and we know, and this is sand. It fulfills our table. Let's see a forest. Where are we located here in? Okay, if this is the canyon, where is Utah State? Okay. Where is Utah State? Maybe I need to turn off. Oh yeah, to north. Here is Utah State. I want to show you one thing about forest that you will recognize. How many of you stare at the mountains? Like, start looking at it and say, huh, weird. Well, I do. Okay. Yeah. Okay. This is Logan. Okay. This is the campus. And I'm doing this view. Do you see this shape that is like, is that water line that divides the north side from the south side of the mountain? This, the peak of the mountain that goes to this Bernew Peak. Okay. I want to see what's the difference between the NDVI facing south and facing north. Let's bring our Landsat image. Okay, we see very clearly the division. We already see, what do we see on the south side of the mountains? Here and here versus the north part. Why? Why in a mountain, the north side and the south side is different?
Sun.
Okay. Yeah. What else?
Maybe soil and like and with more water in it.
Okay. Okay, you're getting close. What happened with the snow?
Okay, here this side gets more light, so snow gets out quickly than that part. So can grow sooner than other.
So when we are in the north latitude or the north hemisphere, okay? So most of the sun rays are going to come from the south, okay? Now, that means the north side will have more shadows. And we discussed the shadows briefly, okay? So that means on the south side of the mountain or the south face, melting or snow water processes will start earlier. So plants or plant seeds that are on that side will start germinating sooner than the ones that are at the north side, because here the snow is still present, while in the other side, the snow has started melting. So while the south slope has already vegetation, on the north side is starting to germinate. So there are vegetation on both sides, but just because the micro local conditions are keeping snow for longer times in the north face, we will see less vegetation on that versus on the south side. The other thing that will this tell us is that if let's imagine there is a creek here, and we depend on this creek that has a large north face, the water supply or the water in the creek might be low during the year, but it might be more consistent along the year because the snow doesn't melt that fast. But if we live on a creek that has a larger south face, we will have a larger runoff, okay, early in the season, and almost little runoff during the mid of the year. So how the mountains are oriented will affect water availability, vegetation occurring there. And the NDVI is, for us, is a way to explain the distribution of areas where vegetation are growing and understand better what are the water vegetation processes in those areas. Fun? Okay. Let's see. Do you recognize these features? This is we are right now here. One of these pixels is us. This is towards the canyon. This is the golf course. It is kind of the same level of greenness. We have spots with the darker blue. This must be the quad. Doesn't look much. This is the quad, and this is the downhill from the quad. And this is the cemetery towards north. So Landsat is not designed to assess urban areas. The resolution, if we want to study vegetation, like what's the amount of green area in Logan City versus Arizona versus Idaho, Landsat resolution is too coarse to tell us this is vegetated area versus what is not. This is where Planet, the 3-meter resolution, comes in handy. For urban areas, the finer the resolution is better. But for agricultural areas and mountain areas, Landsat comes really in handy. We can see also the lake, the Grayson Lake. By now we know that everything that is plotted red .17 no vegetation there. So by looking at this image, we see that not everywhere in the north part of Utah has vegetation. We happen to live in a strip, which is basically the mountains that supports snow conditions or snow retention conditions that allows all this area to have vegetation, either natural or agricultural. And there are areas where the amount of vegetation is very minimal. Fun? Fun. Okay. Till when is our class? 11, right? No, 11:30, right? Okay. All right. More indexes. This is another index you are going to find. This is called EBI. Now, EBI, NDVI has effects from the soil. You can isolate soil in NDVI. So the EBI is an index that looks to focus from this value to the maximum value of NDVI, like removing the effect of soil and water. So just focusing on the canopy itself. So the expression is quite different. This is the third type of vegetation indexes, an equation. The EBI is going to be 2.5 times the EBI. Through a mathematical search, they figured out that this equation can remove the effect of soil. So the pixels only are responding from early vegetation to the highest development of vegetation. We run this cell and we run this other cell. We use the same color map. Oh no, let me see. Let's start at 0. Okay. Okay. Both the NDVI and the EBI are presented here. But here is the NDVI show us a lot of green and blue pixels. Now we have very, very few that reach that condition here at the north. Let's give it a look to these locations. Okay, this is EBI. I can turn off EBI. NDVI will tell me that most of the fields are healthy, overall healthy. EBI is telling me yes, but in terms of only the vegetation, removing the effect of the soil, which you have as part of the NDVI, only these few fields have that characteristic, that are extremely healthy. So EBI is a more refined index for us to use to evaluate vegetation health without considering soil effects. So like let's say NDVI is a cheap thermometer of the dollar store, and the EVI is like the thermometer they use at the hospital. Okay, so the thermometer from the dollar store will tell you the temperature, tell you have a fever, but the exact value probably will come from a thermometer at the hospital. Okay, again, this expression allows us to again do the same, identify the fields that are very healthy, others that are not. Here we probably see better clear. This is like a sort of a previous center pivot that, oh, probably this is not in operation anymore. And this happens when center pivots are abandoned. Like when they are in operation, they look like this, blue or entire green. But when you see yellow spots, dark blue like this, is that probably that location has been abandoned. It's not anymore used in irrigation. Another thing, look at this, interesting. I have a center pivot here. Half of it is healthy. The other half, what is that? It might be, yeah, it seemed like a creek, a previous creek. The value is very low. Let's look at the NDVI. It's green. We have vegetation by the soil, because on a creek you might have more gravel in that area. So water retention on that spot is low. So any plant over that spot will have difficulties to get water. That's what the NDVI is telling us. There is an issue here. If we look now at the EVI, it's telling us, yeah, this location, your vegetation is doing poorly. Here you have an homogeneous area. So it's telling us, pay attention to this area. Or do a visit, do a soil analysis on that location. Fun? So that is remote sensing. Also, that's what we do. We look at the data and look to relate it to hydrological factors, agronomical factors, urban factors, and look to make sense of the data. Okay, the next index is for water. The next index is to determine how much water is in the plant or the soil. The normalized difference water index is going to use one of the shortwave bands, the one that is at 1.4 microns, and is going to use the red band. So it's going to relate water and chlorophyll. Let's run it. Let's add it to our map. Let's zoom out to see what we see here. Here I chose a different color palette. Let's see, what is the water palette? Where did I define the water palette? DPI. Oh, here, from blue to white. And in this case, I plotted from -1 to 1. Let's give a look at an area that has a dark blue. Do you recognize what is this area? Yeah, no, this is Cutler Reservoir. This is the water treatment plant of Logan. So if I zoom in here, that's the first dam. So what are the values of this index for water bodies? Let's query it. Negative. Water bodies in this index are negative. Let's go to the golf course, which is north from the first dam. Let's query what are the values. Positive. So this can be used as a water mask. Negative values are water bodies. Positive values are dry land. So let's say, okay, now we know negative values are water. Let's say we're interested only on vegetation. How should I change my threshold, my -1 to 1, if I'm interested only on dry land?
In dry land?
Yes.
For the water it was close to.
Is negatives.
Negative, so should
All-
value close to
all-
1.
And now if dry land is positive, what should be my range of values mean max if I only want dry land? 0, 1. Very good. If I want the opposite, I do -1 to 0. So I change this to 0. We can change the palette now. We can use the agricultural palette, where is the Scarlet Beg palette. We can put it here. Okay, let's be. Okay. So I have now NDWI, EBI, and NDVI. This is EBI. This is NDVI. NDVI is telling me that the golf course is healthy. The overall health of that location, it's okay. EBI, which is telling me only about the vegetation, is telling me, yeah, we see common green estimation is homogeneous. Good. Let's see in terms of water stress. Same level of greenness. The golf course is well maintained. It's kind of homogeneous. Let's go now to an agricultural farm. Let's look for a center pivot. We saw some center pivots at the north in Idaho. Here. Okay, same exercise. Okay, overall, NDVI is telling me that most of the fields are okay. Those are the dark blues. EBI is telling me yes, but in terms of crop, only these are doing great. The others might be growing slower, or, I mean, the thing is that we don't know what crops are happening everywhere. So if I have alfalfa, they are expected to be healthier early in the year, while corn and wheat, they're planted later. So that might explain why the EBI is seeing healthy locations, and this might be alfalfa, and these others are corn or other vegetation. EBI, though, is telling us that there are only few locations where water stress doesn't seem to be the problem, the dark blues. Let's compare it, EBI with NDWI. Okay, this is very dense vegetation where my mouse is. And I have a bluish tint here. Here, there is no stress, or there are very indication, there are strong indication that in that location, there is a very limited water, vegetation water stress. So every index has a purpose. They try to tell a different story. NDVI, everybody uses it, is an overall health. EBI is if you want to focus only on the vegetation conditions. The normalized different water index is to determine if there are any issues with the vegetation related to water availability, water stress. So the yellowish the area, the more severe the water stress conditions for the plant. Fun? The thing is, there are hundreds of indexes. Okay. Let's see. Water palette. Let's not do the filtering. Let's try to do this one. The NDPSI. This index was developed. I found it what? 5 years ago. It's a kind of brand new. The NDVI is a 20-year-old index or more. But this index allows you to detect, instead of focusing on the plant, it focuses on the soil. It allows you to detect where are bare soil locations in your image. And this is a type of composite index because we're going to add 2 indexes or 2 bands, and then we're going to subtract them and then divide it by the sum of all of them. So this index uses 4 bands. Let's run this cell. We're using a ratio or a range from -1 to 1. So let's see, where are bare soil locations? Well, the best location we know for that is the shoreline of Bear Lake. Okay. I did to activate. Okay, it's negative. The bare soil pixels in the ND bare soil index are negative. Let's check it over here. Negative. If we check a farm area, is positive. So any value, in this index, any negative value is bare soil. Any positive value, it's a pixel with vegetation. So it can serve us as a filter. So if we, let's say we're looking to determine some methodologies request or require that you know the temperature of the bare soil in the area. So this index allows you to filter out with high confidence that these negative values from the index are pure bare soil. And so you can filter them out, or you can select only those pixels. So let's see. Here in this cell, we're doing that filtering. We have our index, normalized difference bare soil index, less than or equal to 0. That this function will create a mask, a zeros and 1. And we will pass that mask to our index. And if we plot it again, we will have only the soil pixels in the image. Let's visualize that. These pixels, the index is telling us that in all these pixels, only bare soil conditions exist. Just a lot. It has removed all the indexes or all the pixels that have some level of vegetation.
So in this case, if everything is just bare soil, what's the difference between colors?
The colors are still respecting the vegetation palette. But I can it's just the changes in values might be responding to soil composition, but not to vegetation anymore. So some areas might have some sand, other areas might have, but overall in the entire image, the level of colors or the range of colors is quite similar. Okay, we're reaching close to the end of this notebook. Snow in satellite images can be detected too. And in snow, in this case, the images that we were using before were for the summer period. Now we need to change to a period where we have the snow. So from December to February, we're going to do the same transformation of the bands. And let's see if we get a image with the snow. Here, maybe it's better if we, that's okay. And look, here is our image with the snow. There is, remember that, have you heard that the lakes, Great Salt Lake has an effect over the weather of that area? This is Logan. This is Bear Lake. This is Ogden. How much snow do you see there? Very minimal, close to 0. The lake acts regulates the air conditions or the weather, the microclimate, the micro weather here. So there is less snow here while we are, but it is snow. Okay, when hydrologists do their studies, they want to know where snow has fallen.
Only. Where is the snow?
Where, which location, which area in my basin or my area of study we have snow. So there is an index for that too. In this case, the index is going to be between the short wave number 2 and the red reflectance. It's just a normalized index. If we run that, it already has detected where there is snow, which is white bluish, while around the Ogden area has detected there is not. Let's query it. The snow has a positive value, 0.72. If we go to the Ogden area, where there is no snow, the values are negative. So what if I want to count or determine what are the pixels with the snow? I have to filter all of those that are 0 or greater than 0. That's what we do next. We take our index, we pass an expression greater than equals 0. That will produce a mask of 0 and 1. To our index, we will apply that mask with this function, and then we can plot it again. Let's see if it did a good job. Okay, this is my RGB image. And this is my mask snow. Overall, it has done a good job. So there are some indexes like NDVI where we're going to evaluate the different values. Indexes like the normalized difference snow index will allow us just to separate between the snow and no snow, or the one that we did before, the bare soil or not bare soil. Other indexes like EBI or the normalized water stress index or the normalized water index will tell us the range of values, will tell us the level of stress or the level of health of the vegetation in that location. There are hundreds of indexes. Let me see.
In case someone wants to like develop with a new index, should follow there's some structure that should follow you.
Good question. What if you want to develop your index? The first thing is what you want to characterize. You want to characterize the biomass, you want to characterize the stress. What is the
Maybe detection, like in case like calculate like canopy cover or something, so not to take the vegetation and soil.
Yeah, I mean, it's what it at the end is first is to look what is the parameter you want to characterize. For example, there is an index for flowering, for like plants develop flowers, okay, and the flowers are not green, are different colors but green. So for it is possible to develop an index that detect non-green pixels used by understanding what is the type of reflection. Instead of getting low red, green, blue, now you get higher. So you can combine like a threshold, you can say NDVI on this threshold versus, I see that if I sum RGB divided, let's say, over near infrared, like the Masomet index, might tell me something about flowering. So I test combination of bands. I try to make them unitless. I define if I want to use a ratio, a simple ratio, or a normalized index. So it's a trial and error. But first you need to figure out what is the characteristic you want to isolate, and then how that characteristic appears in the image. Okay, this is a package for Google Earth Engine that expand the capabilities of GEEMAP, the module that we have been using. The interesting thing about this, let's see, is that, let me see, is that he has created the tutorials to calculate vegetation indexes from EBI, and his module has about 200 indexes already. And I'm trying to figure out where are they. Tutorials, a month. Free catalog. Complete processing here. So this is an effort that is in GitHub that is collecting as many vegetation indexes, and many indexes have been developed in the literature. What are the indices they have? There are 230 right now in that box. Not all of them are useful for us, or not all of them you need to use them. But some indexes are more useful than others. For example, here, the water index that we use to separate water versus bare soil is another version is proposed here. These ones, anthocyanin, is to study the senescence of forest when the leaves turn to yellowish. These are indexes that track that condition. This is a similar index like the EBI that we use it, that remove the effect of the soil, but also of the atmosphere. So this is what is called SAVI. It's an index called SAVI, the SAVI, but an adjusted version of. So for vegetation, we're going to find many indexes. This index allows you to quantify burn areas, like after a fire, like the Australia fires or the California fires. With this index, we can determine which pixels were affected by the fire. So this Again, the same index, but now adapted to the MODIS satellite. So indexes, there are many. There's a second one. Now this is for Sentinel-2. This is a bare soil index. Landsat brightness. This is for, it helps with the studies of albedo. There are chlorophyll index. And you can see here the expression. Near infrared, over green, -1. So depending on what you're studying, you might start with the NDVI, but then to isolate the properties that you are looking for, this bank or this list of indexes can help you to narrow down the characteristic. You are looking at vegetation recovery after a burnout. So you get the area that was burned out, and over that area, you keep tracking NDVI in year 1, year 2, year 3, and see how much greener that burn area becomes over time.
S1, stand for drought stress index. S1 over N.
This one?
Yeah, I see like S1 and like T1s and
Okay, oh, these ones. Okay, let's see where are they. I am not sure, but for each of these index, they provide the paper.
yeah, that's cool.
So this repository of indexes is called in GitHub the awesome spectral indexes. Okay. And they are compatible with Google Earth Engine. So here they have a better table to describe the indexes. If you are studying vegetation, look, these are the indexes and the satellites which you can apply. So you can apply to bodies, Landsat 5, Landsat 7, 8 and 9, Sentinel-2, and Planet. So all of these indexes are related to vegetation and different conditions. This is disease, water stress. Different vegetation index. Here is the EVI that we just studied. We saw it. Fluorescence correction vegetation indexes. This is the fluorescence index is to study how efficient is the chlorophyll process in plants. Like the plants, and this is a very weird property that plants at extremely very narrow wavebands shine in the optical region. Okay, but it's very so the algorithm has to be very sensitive to that to see that brightness of the plant. So nowadays, since that we can replicate that fluorescence with many satellites already. So all of these are vegetation indexes. Vegetation has, we have paid a lot of attention to vegetation. Here is water. If you are studying water bodies, these are indexes exclusively to study waters, water and sediments, water and vegetation, algae presence in the water. If you are studying burns or wildfires, indexes that can be used. If you are studying snow, if you are studying urban areas, how to extract buildings or man-made constructions, build up area radius. impervious surface estimation, indexes exclusively for soil. Now, after that, it comes indexes that looks to transform the data into artificial intelligence values, but can be also interpreted by looking at the scale of values that being produced. Also, this list produce indexes to use with Sentinel-1 radar data. So to look at vegetation conditions, to look at forest degradation, and so on. And this is not a complete list. There are other lists. There are hundreds of vegetation indexes. Okay. All right, let's stop here. I'll prepare an assignment based on what we have done today. What basically is you creating a new notebook as you did for the previous assignment, where you will implement other vegetation indexes. You will retrieve the Landsat or the Sentinel imagery, and you will implement other indexes that are in this list and see what you can implement. Okay. All right, questions? Well, there are no